Okay, so this is the second lecture on 8.5, and we just finished solving this integral by partial fraction decomposition. And yeah, let's write a little note about this. You know, when you have a factor or you know, binomial, well, we have something here, right, in the numerator, and let's say we have x minus 4 to the third power. Okay, so then we need 3 partial fractions. So the first one will have a factor, the linear factor, right, like this. The second one will have quadratic, so x minus 4 squared. And the last one will have the cubic factor. Okay, something like this. Let's look at, maybe I want to do the whole thing, but I just want to show you something. So example 3. So we need to solve an integral, looks like this, minus 4x minus 8. And here on the bottom I have x times minus 1 times x squared plus 4. So you see that, right, I cannot decompose this cannot factor this to linear factors. Okay, so what I need to do is something like this. I'll have that, let me just rewrite it, so 2x cubed minus 4x minus 8 over x times x minus 1, and now x squared plus 4. So I'll have this a over x, right? Then I'll have plus b over x minus 1. And then here, this is different, right? So I'll have this quadratic factor here, x squared plus 4, right, that I cannot decompose into linear factors, right? Like over here, right, I was still able to decompose this into linear factors, but here I cannot, right? So that means that here on the top I need to have a linear factor. Okay, so then looks like I ran out of nice paper, but that doesn't matter. So what do I have? So now I'm finding that common denominator, or I'm rewriting it with those coefficients a, b, c, and then x squared plus 4. So I'll have a times x minus 1, x squared plus 4, as b, x squared plus 4. Now I have that linear factor cx plus d, and then times x minus 1. Okay, so you know, I'm just gonna do it kind of quickly, right? Because it's you know, interesting algebra, but not really calculus, right? So I have that numerator here, and that numerator was 2x cubed minus 4x minus 8. So now I have that long numerator of the other expression of the left side, plus 4 plus bx times x squared plus 4 plus cx plus d times x minus 1. And you know, we're just gonna pick our x's. So again, so x, yeah, if I pick x equals 1, right, if x equals 1, I'll have just this term, and if you do your arithmetic, you're gonna get b equals -2, and then we can pick x equals 0. We're gonna get a equals 2, and then right, we can keep going with different numbers for x's, and we're gonna get something like this. I'm not going to finish, as my only point was to show you that when you have a quadratic factor, right, so x squared, that you cannot decompose into linear factors, you need to have a linear factor on the top, right, in the numerator. Yeah, so let's write some kind of conclusion. And let's just say, if you, or if we have single quadratic say x squared plus 9, use ax plus b, right? So linear factor on the top, or linear expression over x squared plus 9. So for repeated quadratic factor, for example, something like this, so x squared plus 9 to the third. Alright, so we need to use something like this. Alright, so this is ax plus b. So this is just a single quadratic factor, right? Then cx plus d, so this one is going to be repeated quadratic factor, right, squared, so 2 of those, plus, what is next, ex plus f, and x squared plus 9 to the third. Okay, so something like this. So you know, when when you guys are I don't know, taking your exam, right, I will not be asking you to, you know, to do an integral like this, right? What I'll be asking you is, like, you know, set up partial decomposition. Okay, so something like this on the next exam. So let's say, you know, I have 2x minus 3 on the top, and here I have x cubed times x, what is it, x squared plus 1 squared. Okay, so well, I would like you to decompose this, right, this denominator, right, and the numerators into those partial fractions. So maybe, you know, try it. Pause the video and see if you get it right. Alright, so let's see. So first I need to deal with this one, right? So this is just a regular linear factor, right? So I'll have, So that will be, or this expression, right, will be equal to a over x plus b over x squared, right? I don't need linear factors here. I just need constants here, because even though this is x squared, I can still decompose it, right, into x times x plus c, and now x cubed, and now I need to deal with this one, right? So I'll have my, you see, dx dx. I hope I'm not going to run out of letters. So I'll have just one of those, and then I will need two of those. And what is that? Okay, this is, let's do this. Let's do E. Let's change it to E. I don't know, I had F there. Anyway, so after E is F, and then G. Okay, so this is what I'll be asking you to do on the next exam, or on the final, I don't know. Okay, so there's another thing that you need to watch out for. So when degree, or numerator's degree, is larger or equal than denominator's degree, then of course we need to divide it, right? We need to do long division. So x squared over x minus 5 dx equals, right? So if you divide it, you're gonna get your quotient x plus 5, and then remainder, right? 25 over x minus 5. Right? So we don't need to do any decomposition. It's a pretty easy integral. Okay, so let's look at a couple practice problems. Right, we've been doing integration for quite a while now, and yeah, I wish I had more problems here. Anyway, I have a couple problems for you to just kind of figure out how would you do it, right? Because that's probably the most difficult part of doing those integrals, right? Like once you know that it's a substitution, especially if you know what to substitute for u, then it's quite easy, right? But knowing what to do is the difficult part. So if you have something like this, or maybe I'll write the problems, and I don't think you need to necessarily do those problems, but I would like you to figure out how to do them, or propose some kind of method of solving this, or finding the antiderivatives. Okay, dx, and the last one, it looks like this. So x squared plus 4. Okay, so pause the video, think about it, and propose some kind of method for solving those. And yeah, so I hope you've done it. So first one, right, you can do substitution. So I guess u would be the whole thing, right, the whole denominator, plus 2x minus 8. Because once you differentiate this, right, you're gonna get 2x plus 2, which is almost the same as this, right? You just factor 2 out. You can also do partial fraction. Okay, so that's the first one. The second one here, right, substitution would not work, so this one is partial fraction. Decomposition. And the last one was a trick question, because it looks kind of like sine, right, or inverse of sine, like arcsine, but arcsine is actually slightly different, right? So it looks like, so you have your 1 or some constant here, dx, and here you have constant squared minus x squared, okay? But be careful, right? Don't assume that this is an arcsine, right? That you can take an integral like you would with this. Okay, it also looks a little bit like arctan, right? Arctangent, inverse of tangent. Right, but that arctangent doesn't have that square root, right? So keep that in mind. So 1 over a squared plus x squared. Okay, so in fact we don't know a method to solve this, right? To find that antiderivative. So that would be a trigonometric substitution, but we haven't covered this topic, and I don't think it's in the curriculum. Anyway, maybe I'll write it down if you guys want to look it up. Nothing too difficult. Trigonometric substitution. Okay. So that's it. I hope that was clear. There was a lot of pre-calculus and algebra, and not too much calculus. Anyway, I'll see you next time.